So I've uploaded all of our previous videos. That is now, the YouTube is up to date, just in case you kind of need to go back on anything. But so we're going to finish up this topic here because I'm pretty sure that finishes it up. Yes, it is. Just kind of a quick summary of what we've been doing. We've looked at the experimental probability of things that happen to draw conclusions from. We've also looked at the theoretical probability, like how should it work in theory. Doesn't always work that way in practice, right? If you go to a roulette table, you put all your money on red, sometimes you can lose 4 times in a row, right? That's a very rare occurrence, but it can happen. So now where we're kind of going with this is we're looking at odds and probability. This is our last little part here. So now we're looking at odds and probability. How can this apply? You know, and where are you going to use this the most in real life? Honestly, if you go gambling. So we're just on page 163. I'll give you a moment just ahead there. It's not going to be a long one today. So we're looking at odds and probabilities today. So basically, you know, if you ever see the terms of, hey, the odds of winning the hockey game are like 3 to 1. Well, what does that actually mean? That's kind of like that's the type of stuff that we're looking for. You know, what's my odds of winning this blackjack hand? It's 2 to 1, stuff like that. So odds are similar to probability. Probability of me pulling a heart from a deck of cards is 1 out of 4 or 25% or 0.25, right? So odds are similar to probability, but if we compare the number of desired events to the number of undesired events, but we're looking at undesired events. So right now, if I'm like, hey, I want to know, like, what if I want to pull a heart from a deck of cards? This right here is probability. But at the same time, what if I want to know the odds of it? I'm looking at the odds of a desirable outcome. It'd be 13 out of 39 because I have 13 desirable outcomes, but 39 undesirable, which turns it into 1 to 3. So I hope that's showing some of the difference there. So if we're using the same example with what about the hockey team? The odds of our team winning the hockey game are 3 to 1. Well, if we look in the past 4 games, that team has won 3 times. The experimental probability, right? Because that's an experiment, is 3 out of 4. So the odds in favor of winning, however, are their ratio of wins to loses. Desirable outcomes, winning, versus undesirable outcomes, losing. They won 3 times, they lost 3 times. So it's 3 to 1. So that's kind of the difference here. So the word in here is really, really important. The math itself is not hard, right? Like those are simple enough concepts, but the wording and thinking about, okay, is this probability or is this odds? That's where it's important. That's where there's a distinction. So odds are a ratio that compare to the desired events odds are a ratio that compare a desired event to the number of undesired events.
So if it was like for example, like ace of spades, would that be a 1 to 51?
That would be a 1 to 51, yeah.
Okay.
Yeah. So yeah, there's a very small difference here. And it is normally as a ratio. You can do it as like a, actually, no, I'm not even gonna go that. Keep it as a ratio unless it says otherwise. Let's just keep it simple. Okay. So odds can be written in favor or against a particular event. The wording is important. Where are you going to slip up in this chapter is just, you know, sometimes your eyes glaze over and you think you know what you're doing and like read the question twice, right? It's a really important skill to have. There will be some easily misinterpreted questions on your final exam where you just misinterpreted a word. So odds can be in favor or against an event. The hockey team's odds of winning in this case, the hockey team's odds against winning is the ratio of losses to wins, or 1-3. Their odds of winning are 3-1. So the wording is important. Okay, so let's actually take a look at an example of this. So if I roll a standard 6-sided die, you know, right? You can only have 1, 2, 3, 4, 5, or 6. What's my odds of the following? Well, question A asks us in favor of rolling a 6. So remember, we always do desirable outcomes to undesirable outcomes. You don't need to write this down every single time, but again, I'm just showing you as an example. Most people are just going to go straight to the answer here, which is fine. What's our desirable outcome here?
1.
Well, that's what the number is, but the desirable outcomes roll in a 6, of which there's only one way I can do that, right? And then how many are those are undesirable? It's 5. It's 5. It's not 6. That's the odds of it. So that's the probability of it, but these are the odds. Okay, so it's a 1-5 odds, but it's a 1-6 probability. Okay, so that's the difference here. And specifically, this is the odds in favor. Okay, I'm just gonna get rid of that, actually. Here. Those are the odds in favor. There we go. Which means, well, what about my odds for against the 6? Again, what's my desirable outcome there?
6.
Anything but a 6, right? So there's only 5 options there, and there's only one way I can roll a 6. So it's a 5-2-1 option now. Okay, so we're trying out this one, you know, so again, you're going to notice a lot of the themes of this chapter. What is it? Dice, cards, simple things like that we ideally, they're not going to try and hit you with a curveball and stuff. If they do, it's going to be, here's a spinner. Here's a picture of the spinner with the icons on it. So their goal here is not to give you a trick question, but you do need to know there's like 52 cards in a deck of cards, for example, right? So with this one here, what's our, if we have a card that's randomly chosen from a deck of playing cards, 52 cards, what are the odds? The key word here is odds. If this said probability, we'd be given an entirely different answer. So what are my odds in favor of it being a diamond? So what's my desirable outcome?
3 cards.
Sorry? It's a diamond, right? How many diamonds?
Is there 13?
There's 13, yeah. If you're ever unsure, you're in the exam, like, oh crap, literally just go 2, 3, 4, just list them all out. And they don't include jokers, okay? They don't include jokers. So desirable outcomes are diamonds, of which is 13. What's the undesirable outcomes? Well, it's not a diamond. How many of those are there?
39.
39. Yeah. How did I get that 39? 52 minus 13. So what's my ratio then? It is a 1. Well, technically it's a 13-9 to 39, but you're right. We simplify this to a 1-3. You always try to simplify. Specifically, in favor odds. I recommend writing that for at least the first couple times you do this, right? Just embed that into your brain a little bit more. But our odds here are 1-3. Now, what about against it being a queen? The key word here is the favor and against, and then what the actual outcome that we're looking for is. So again, if that's the case, what's my desirable outcome?
Queens.
Well, right now I am against it being a queen. I do not want a queen.
So cards except queens.
So every card except a queen. So non-queens. Of which that's probably 48, right? And that's if that's the case, well, my undesirable outcome now is queens. I do not want a queen. It's against being a queen. Is 4. So what would my odds be here then?
48 to 4.
48 to 4, yeah. Which if you simplify is going to give you 12 to 1. So give me a second, just make sure everything's been down there. Okay, so just like before, you got 2 more questions. You got question 2 and question 3. Give you about 3 or 4 minutes for that. Not a long time. Just 3 or 4 minutes for it. And I will go over the answers for this one. I'll just kind of spit them out. If you have questions, you let me know. But we will be going over I will spit out the answers for those. Oops. Now, if you have any questions on like stuff like this, wait a minute. How did I do that? Sorry. If you have any questions on something like this, feel free to ask. But now, just kind of throwing you a curveball. What if we what if we use odds to find probability or probability to find odds? We go the other way. So with example 3 here, what it asks us, it says, hey, we have an animal shelter and it's holding a raffle to raise money to build a new room on an existing building. They offer a bunch of prizes, like a free pet visit, bags of food, so on and so forth. The key thing here is 4,600 tickets were sold, and the odds in favor of winning a prize are 3 to 227. So 4,600 tickets were sold, and the odds in favor of winning a prize are 3 to 277. Break on here. Here we go. So what does this mean? So we want to find the probability of winning a prize. The probability of winning a prize. We have to figure out how many winners are there. We know how many total tickets there are. We need to figure out how many total winning tickets. How can we do that with this? We only have 2 numbers to work with. This 3 to 227, these odds, and the total number of tickets. How can I work backwards to try and figure some of this stuff out now?
3 tickets and 230 tickets total.
So you're saying that this is, if I convert this into probability, it's 3 out of 230? Yeah, that's right. So this is the probability of it. Now, how can I use this and this to figure out how many total winning tickets there are?
How many total?
Total tickets. That's what, because we want to know what's the probability of winning a prize. Well, sorry, no, you've done it already. Sorry, you've actually done that already. Yeah. So question A. Sorry, I'm working a little bit ahead here. My bad. So question A is, well, we want to convert odds to probability. Remember, the probability of a win, probability, not odds, is the number of events of interest. Obviously, I'm interested in a winning ticket, divided by the total number of possible outcomes. Well, that is all tickets. Not all tickets, sorry. Oh, how do I do this? Other outcomes? of the 230. This is not of the 4,600. So basically, well, I know that there are 3 winning tickets out of for every 230 that are drawn, right? So not other outcomes, total outcomes. Let's nip that. So there's 230 tickets. Now, you can leave it as 2 out of 30. You could 3 divided by 230. You could turn that into 0.13 or something. I recommend a fraction unless it asks otherwise. It's just more accurate. 3 out of 230 chance, or about a 1% chance. Now, question B, however, asks us, well, how many prize winning tickets are there? Now we need to use this information. We know what the odds and the probability of winning a ticket are. We know both of those, but now I got to figure out, well, how can I use this information to figure out the total number of winning tickets? Now, how can I do that?
You would take 3 over 3, 230, and you would times that by 4,600.
Yeah, that could work, right? So that's one way. So there's 2 different ways of doing this. I'm gonna kind of flesh it out. So we're gonna use what's called proportional reasoning. This is a ratio, is really what it is. So what does that mean? Well, I know that there's 3 out of 230 winning tickets. But how do I figure out how many total of 4,600 tickets there are? If you took math with me last time, you're recognizing this problem. Sometimes, in this case, you could either use algebra or you could do, 230 times some magical number to get to 4,600. That could work. I'm going to use algebra at this point, just because I don't want to have to reteach that whole concept over again. That took us 2 days. So instead of a question mark, I'm going to put an X. I'm going to use proportional reasoning and algebra here. So basically, what am I trying to figure out? I'm trying to figure out what X is. This is what I want. How do I figure this out? Well, I need to get rid of the stuff attached to X. In this case, I need to get rid of this 4,600. How do I get rid of divided by 4,600? I times by it. Which means those get canceled out. But some weird stuff happens over here. So 3 out of 230 times 4,600. 3 out of 230 times 4,600. Write it exactly how it's supposed to be, like that. 3 out of 230. I'm just following the line going down. 60. So in this case, I can see that 60 is equal to X. And if that's the case, that is my winning ticket. So there are 60 total winning tickets. That's way 1 of doing it. Now there is another way, and this works if you understand what you're doing. If you don't, I recommend the algebra. So that's one way. At the same time, I know what my odds are. I know my probability. What's my, if I say, hey, if I flip a coin 12 times, how can I figure out that that's going to be heads? You give me a mathematical reason, not, I know that, hey, I have a 1 in 2 chance of flipping heads. Why don't I apply that to 12 coin flips? Well, I can do the same thing with this, just harder numbers, right? So I know that I have a 3 out of 230 chance, not the odds, I'm looking at the probability. 3 out of 230 probability of rolling a winning ticket. I know there are 4,600 total tickets. You could just skip straight to this step if you don't want to do the algebra, which would also give you 60 tickets. Either one of these works. We just have to think really, really carefully about it. So what's gonna happen now is basically for the rest of the day, like that's it for stats. What's gonna happen is you can finish the workbook and you can finish the assignment. You might want to do it the opposite order, honestly. Like, I don't want you guys to come back to your assignment 8 days from now and be like, oh crap, what do I do? So if you want to just go straight to the assignment, that's not a bad idea right now, just because of the break. But you're finishing the workbook, you're finishing the assignment. I do not think we'll have a concept check for this one, or if we do, it's probably going to be like mid next week or something. So either the concept check will be on the February 28th, or there will not be one. And we'll find another way to make sure like we're able to kind of assess this, or it won't count towards your grades or something. I did not want to spring a surprise one on you today with that. And I don't want to give it to you 10 days after. So depending on how we're feeling with this, when we come back, like you'll get a chance to put your voice to this, whether you want to do it or not. Either we will not do this. I will just use your final exam or like an assignment or something to show that you have these concepts, or we will do it one when we come back, but we're not doing one today. So I recommend though, try out these next couple of questions, at least 7, 8, 9. Those are the hard parts of this. You're going to see one of those, a similar question. You're going to see exactly a 7, 8, or a 9 on your final. 100% it's going to be there. So this is your chance to practice that skill while it's fresh.